Claudius Ptolemaeus, or Ptolemy, was a Greco-Roman polymath whose most influential work was his treatise on astronomy, a summary of the astronomical knowledge of the time. His geocentric, that is, Earth-centered model of the universe remained the accepted view for the next 1,500 years, until the 17th century. The Ptolemaic system was based on the observable apparent motion of celestial objects. In this system, the center of the universe is the Earth, which all the other celestial objects orbit on circular paths but at different speeds. Nicolaus Copernicus was a Polish astronomer who formulated the heliocentric or sun-centered astronomical model. By doing so, Copernicus had an enormous influence, as he removed the Earth from its place as the center of the universe. This had a fundamental impact on philosophy and science, a change that has come to be called the Copernican Revolution. Tycho Brahe was a Danish scientist who became an important figure in the history of science, primarily due to his exact astronomical observations and measurements. He took Johannes Kepler on as his assistant and handed over to him the results of his measurements and observations. Brahe's exact astronomical observations formed the basis for Kepler's 3 laws of planetary motion. Johannes Kepler was a German scientist who achieved a scientific breakthrough by describing planetary motion. For metaphysical reasons, Copernicus assumed that planets moved in circles. However, this assumption is not borne out by observation. It was Kepler who later introduced the idea of elliptical orbits, which greatly simplified the heliocentric model. In elaborating the 3 laws of planetary motion, Kepler relied on the exact measurement data provided by Tycho Brahe. Giordano Bruno was an Italian scientist who asserted that the sun is not the center of the universe, but that stars are also suns orbited by planets on which life may exist. Apart from cosmology, Bruno studied philosophy, theology, and magic. He was condemned to death by the Inquisition for heresy and burned at the stake in 1600. Galileo Galilei was an Italian scientist who is considered one of the founders of modern scientific methodology. He laid the foundations of the experimental method, which allows for studying phenomena under controlled and methodological conditions through repetition. Galileo was a proponent of the Copernican heliocentric model. He proved that objects fall with the same acceleration regardless of their mass, if we do not take into account air resistance. He formulated the Galilean principle of relativity, which Einstein implemented in the special theory of relativity and applied to all physical laws, including Galileo's mechanical laws. Sir Isaac Newton was an English physicist and philosopher who, by formulating differential and integral calculus, laid the foundations of calculus. He studied optics and the nature of light, developed a type of telescope which was later named after him, formulated the law of gravity, and laid the foundations of mechanics. He concluded that forces change the state of motion of objects, and that thus no force is required to maintain their motion. This view is contrary to the theory dating back to Aristotle. Newton assumed that the same force, that is, gravity, that acts on earthly objects also controls planetary motion. He thus unified celestial and earthly mechanics. Even today, he is regarded as one of the most influential physicists and mathematicians, as well as one of the founders of modern science. Albert Einstein was a German-born physicist and philosopher of science who is considered to be one of the most important physicists of the 20th century. He developed the special theory of relativity, which revolutionized our understanding of space and time. According to the famous equation E equals mc squared, mass and energy are interconvertible. This principle is used in nuclear power plants and nuclear bombs. The general theory of relativity provides an explanation for gravity. According to the theory, due to their mass, bodies distort space-time. This distortion determines the path of bodies moving in the gravitational field. By studying Brownian motion, Einstein proved the atomic structure of matter. In addition, by explaining the photoelectric effect, he demonstrated the particle nature of light and the presence of photons, for which he was awarded the Nobel Prize.